Hello and a pleasant day. I am Adrian Samson, here to present to you my DYOE experiment entitled The Human Body Kinematics of Human Motion. So, the objectives of this experiment are find the difference and relationship between the velocity versus time graph and a displacement versus time graph of a person in constant velocity in both moving away and towards the origin and along a straight line with increasing speed, be able to understand and mimic the given displacement versus time graph and velocity versus time graph, be able to analyze, tabulate, and graph a person's motion in a given time frame, and be able to expound on how reaction time can vary across from person to person and circumstance to circumstance. So, for a brief understanding of the theory of this experiment, speed is a scalar quantity that refers to the rate at which an object covers a distance. It is also known as the average speed, since it shows the distance over time ratio and is given by the formula distance over time. Velocity, on the other hand, refers to the time rate of change of the position of an object. The change in position from starting point to an end point is called a displacement. The following formulas determine the computation for displacement and velocity, with x referring to position, f for final, and I for initial, and t to time. Acceleration, on the other hand, is a vector quantity that refers to the time rate change of an object's velocity. Anytime a change in velocity occurs, the object is said to be in constant acceleration. So we move on to the materials needed for the making of this experiment, which are the following: Logger Pro, which is an app, a meter stick or ruler, and a stopwatch. So for the procedures of this DYOE, there will be a total of 4 experiments to be done, namely, determine the graphs for human motion and uniformly accelerated motion in the graphical analysis of human motion, graph matching, graphical analysis of motion, and the test of reaction time. So here are the following procedures of each experiment. So to determine the graphs for human motion and uniform accelerated motion in the graphical analysis of human motion, here are the following steps and procedures that we need to take. So firstly, we need to prepare the necessary materials for the experiment, which is only Logger Pro app for this experiment. Then we need to log in our respective Logger Pro app. Then the third step is we need to envision what a certain situation might resemble when graphed. Like let's say when a person is in constant motion, etc., etc. Then we log and type the respective situation in the app. So take note, the results were predicted by drawing the displacement versus time and velocity versus time graphs in various conditions. Through the program, graphs of motion were produced within different conditions. For graph matching, again, we need to log in our respective Logger Pro app. But secondly, a position versus time graph and velocity versus time graph was reproduced by matching the given graph using the motion of an object. So for the graphical analysis of motion, we first need to find representatives that are willing to partake in the experiment. So each representative will walk in a straight path for 10 seconds. Then we record your observations through the stopwatch. Then, lastly, we tabulate and compute the data given. And for the final, which is the test for reaction time, first need to find representatives that are willing to partake or participate in the experiment. So basically, each member is tasked to catch the meter stick or ruler suspended by another member of the group with the thumb and index finger. So after that, we record our observations for the first segment. Now, for the second part, sparingly, each member is tasked to catch the meter stick or ruler again, suspended by another member of the group with the thumb and index finger. But this time, the representative will be doing so whilst the member is distracted by talking to another member. And then, lastly, we record our observations for the second and last segment of the experiment. We now move on to the data analysis. For Activity 1 Graphical Analysis of Human Motion, the displacement versus time graph and velocity versus time graph of a person moving away with constant velocity from a chosen starting point for a period of 10 seconds were first predicted and sketched shown in Figure A, 1A, and produced using the Logger Pro app shown in Figure 1B. From the displacement versus time graph, it is shown that the line is moving in an inclined positive direction, where the displacement of a person will increase as time also increases, since the person is moving away. From the velocity versus time graph, it is shown that the line is parallel to the x horizontal value, since the velocity of the person moving is always constant as time increases. The person's starting position is higher than zero, since the person is moving away from the origin. The second task was for a person moving toward a chosen starting point with constant velocity for a period of 10 seconds. From the displacement versus time graph, it is shown that the line is moving in a decline negative direction, where the displacement of a person will decrease as time increases. This is because the starting position of the person is away from the origin, and as he moves towards it, the person's displacement decreases. From the velocity versus time graph, it is shown that the line is parallel to the x horizontal value, since the velocity of the person moving is always constant as time increases. The x values are negative since the person is moving towards the origin. Finally, the third task was for a person moving away from a chosen starting point along a straight line with increasing speed for a period of 10 seconds. From the displacement versus time graph, it is shown that the line is gradually increasing over time, since the speed of the person is increasing over time. The velocity, on the other hand, is moving positively in a diagonal line, since the speed is increasing constantly over time. It is not clearly seen in the produced graph since getting higher values of velocity would need higher displacement as well, but this cannot be done due to limited space. For activity 2 graph matching, a position versus time graph and a velocity versus time graph was reproduced by matching the given graph using the motion of an object. For the first graph, the given graph is shown along with the attempt at reproducing it. To reproduce this, the person had to hold the object 1 meter away from the scanner and wait to give a consistent zero displacement. The person then had to move away from the origin with constant speed to match the inclination of the black line. After this, the object stayed put and then moved towards the origin again with constant speed to match the decline of the black line. Finally, the object stayed put again to match the horizontal line, where there is no movement detected or no displacement. For the second graph, the given graph is shown along with the attempt at reproducing it. To reproduce this, the object stayed put for a few seconds and then quickly moved away to match the positive straight vertical line, which means an increase in velocity. After this, the object was moved at a constant speed and then stopped to rest again. The object was then moved towards the scanner quickly to match the negative straight vertical line and then moved at a constant speed. For activity 3, graphical analysis of motion, the following table shows the total displacement, average velocity, and instantaneous velocity in relation with time. Based on the results, although it can be seen that the student increased in displacement over time, the student was not able to achieve constant velocity every second due to limited space in the working environment. And with that, these are the graphs that show the total displacement versus time graph and instantaneous velocity versus time graph. Finally, for activity 4 reaction time, the following table shows the reaction time of catching a meter stick by the members of the group. The table shows the reaction time of the members of the group while dropping a meter stick without any signal and another while the other members are distracting the person doing the experiment. Based on the table, Ray had the best reaction time with 0.13 seconds without distraction, while Francis had the best reaction time with 0.15 seconds while being distracted by the other members of the other group. This is the case because some factors are outside our control, such as age, left or right handedness, and whether the stimulus is visual or auditory. Other factors that affect reaction times are within our control, like our level of physical fitness, the presence of distractions, and how much fatigue we are experiencing. Now, I am going to show you a video of the making of this experiment, or how the procedures were done.